Welcome to Statistical Concepts. Hello everyone, today we'll be discussing a very important statistical concept, correlation. This concept helps us understand the relationship between variables and how they interact with each other. So, what is correlation? Correlation measures the strength of relationship between two variables. It ranges from -1 to +1, where -1 indicates a perfect negative correlation, +1 indicates a perfect positive correlation, and 0 indicates that there is no correlation. There are different methods of finding correlation. These are Karl Pearson coefficient or the covariance method, denoted as R. We have the Spearman's rank correlation, denoted as Spearman's rho. We have the Kendall correlation, denoted as tau or Kendall's tau. We have the phi coefficient, denoted as phi. We have point biserial correlation, denoted as RBP. We also have others like Kramer's V correlation, but today we'll be focusing on Karl Pearson coefficient of correlation. The Karl Pearson coefficient correlation measures the relationship between two variables. To calculate Pearson's correlation coefficients, we first need to calculate the means and deviations of both variables. Let x and y be the variables with n data points. The formula for Pearson's correlation coefficient is given by R is equal to covariance of xy all over the covariance of x multiplied by covariance of y, which is equals to the summation of dx dy all over the square root of summation of dx squared multiplied by summation of dy squared, where dx equals to xi minus x bar and dy is equals to yi minus y bar, where I is equals to 1, 2, up to n. For example, suppose we have the following data for height and weight for men, x representing height and y representing weight, and we want to find the correlation between them. To find the solution, first we calculate the mean of x by summing the values of x and dividing by the number of terms of x to get x bar, and same for y to get y bar, so that we can find dx and dy, which is the difference of x and y values with their mean. Then we multiply dx and dy to find dx dy and square dx and dy to find dx squared and dy squared respectively. Finally, we find the summation of values of dx dy, dx squared and dy squared, which we will put into our Pearson's formula we had seen earlier. The summation of dx dy from the table is 3.25. The summation of dx squared is 0.025, and the summation of dy squared is 426. We can now input the values to the Pearson's formula for correlation. R is equals to 3.25 all over the square root of 0.025 times 426. 0.025 times 426 gives us 10.65, and the square root of 10.65 gives us 3.26343377. If we divide 3.25 by 3.2634337, we get 0.9959 as our correlation. Therefore, the correlation coefficient of height and weight is almost 1, which indicates a very strong positive correlation. Next one, we'll talk about Spearman's rank correlation. Thank you for watching. Make sure to like and comment. Bye.